Hi guys, good day. It's me, Teacher MJ. Our topic for today class, it's all about writing expressions with rational exponents as radicals and vice versa. So without further ado, let's do this topic. So this rational exponents class, we convert this one into radical, okay, this form. And this radical form, we convert this one into rational exponents. Once again class, we call it rational exponents if the exponents are fractions. So example, we have 2/3, 1 half, -3/2, -4/5. So this is actually requested from our subscribers. What if, sir, if the exponent is negative? How to convert this one into radical form? Alright, so do not be worried class, we will be explaining this one step by step. So let's start. Once again, we call this rational exponents if the exponents are fractions. And we convert this one into radical form. Alright, so let's have first an equation class. If you have a raised to the power of m over n, so once again, this a here, if you still remember on the laws of exponent, this a is what we called our base, and this m over n is what we called our exponent. Do you still remember class on the laws of exponent? Now you want to convert this one into radical form. So once again, you put a radical symbol. So radical symbol. Now this a here, you put it inside the radical symbol. Alright. And this n, the denominator, will be your index. You put n here. This will be our index. And this m, the numerator, will be the exponent of a. And that's it, class. That's the answer there. Easy, right? So once again, in this radical form, you can read this one as the nth root of a raised to the power of m. Nth root of a raised to the power of m. So once again, this n in the radical form, this is what we call the index. And this a raised to the power of m is what we call the radicand. And of course, this symbol is what we call the radical symbol. So that's how you convert class. Very easy, right? So once again, let me explain it to you again. To convert this one, this rational exponent into radical, copy a, you put a inside the radical symbol, and this n, the denominator, will be the index, and this m, the numerator, will be the exponent of a. And that's it, class. That's how you convert rational exponents into radical. Easy, right? Now you can also write this one, class. This is actually the same with the quantity of nth root of a, nth root of a raised to the power of m. So this is actually the same, class. You can have this answer, you can have this one. Once again, nth root of a, okay, nth root of a, quantity nth root of a raised to the power of m. So it's either of these two, class. This is actually the same. So you can have this answer, you can have this answer. Nth root of a, quantity nth root of a raised to the power of m. So actually, you can have this answer, class, to make it simple. Alright, so let's answer 1 to 5, especially for numbers 4 and 5, requested from our subscribers and our followers. What if you have a negative exponent? How to convert that one into radical form? Alright, let's try number 1. So if you have x raised to the power of 2 over 3, once again, you put a radical symbol, and you put this x inside the radical symbol. Alright. And then this 3. So 3 will be the index. And 2 will be the exponent of x. That's it, class. That's the answer there. Or you can also have this answer. Okay. Quantity, the cube root of x raised to the power of 2. So it's either of these two, class. Cube root of x. Quantity, cube root of x raised to the power of 2. So you can have this answer, or you can have this answer. This is actually okay, class. So let's have this answer. So you can read this one, cube root of x squared. Cube root of x raised to the power of 2, or cube root of x squared. That's the answer for number 1. Easy, right? So cube root of x raised to the power of 2. Alright, let's try number 2. So what if you have 3 raised to the power of 2 over 3. So this is equivalent to, once again, put a radical symbol. Alright. And then this 3, this one, you put it inside the radical symbol. And this denominator 3 will be the index. You put it here. And then this 2 will be the exponent of 3 inside this radical symbol. Right? This 2 will be the exponent of 3. That's it, class. That's the answer there. Easy, right? So that's how you convert, class. Now, there are some teachers that they will advise you to simplify this one. Actually, class, no need to simplify. Now, why is that, sir? Why is that no need to simplify? Because we are just told to convert this rational exponents into radical. Because the next part of our video, class, will be simplifying radicals. So once again, the next part of our video is simplifying radicals, and we will explain that one, how to simplify radicals. But if the teacher will really insist to simplify this one, you can simplify this one, class. 3 squared. What do you mean by 3 squared? 3 squared, class. Is it 3 times 2? Nope. It's actually equivalent to 3 times 3. And 3 times 3, that is 9. So 3 squared is equivalent to 9. So you can have this answer, class. Or, so simplify this one. This is the cube root of 3 squared. It means 9. Cube root of 9. That's it, class. Cube root of 9. So you can have this answer if you can have this answer. But actually, in our video today, this will be acceptable, class. Sir, why is that? Because we are just told to simplify or to convert rational exponents into radical forms. To convert rational exponent into radical form. No need to simplify, class, because this will be the next part of our video, simplifying radicals. Alright, that's the answer for number 2. Let's try number 3. Alright, so what if you have, once again, the answer for this one is the cube root of 3 squared. Let's try number 3. So 7x raised to the power of 1/2. Now, in this scenario, class, do not be confused. This 7 here, the exponent is 1. Okay, once again, do not be confused. The exponent of 7 is 1. So, do not include 7 in the radical. Okay, do not put 7 inside the radical, class. Why is that, sir? Because the exponent of 7 here is 1. Only x has a rational exponent. The exponent of x is a fraction. So therefore, this x only has a rational exponent. But for 7, the exponent is just 1. So simply copy 7. Alright. And then you put a radical symbol. So do not include 7, class, on the radical symbol because the exponent of 7 is 1. So never include 7. We only convert those equations, class, with rational exponents. And 7, the exponent of 7 is 1, so do not include 7. So put this 7 outside the radical symbol. And x, put it inside the radical symbol. Now this 2, class, the denominator will be the index of this square root. So 2 will be the index. And this 1 will be the exponent of x. Now, this time, class, no need to write 2. Why is that, sir? Always remember, class, that in every square root, the index is 2. Okay, imaginary 2 there. So once again, always remember this one, that in every square root, the index is 2. So we can erase 2, understood that there's 2 here. And then for x, we can erase 1. Why is that, sir? Because understood that any variable, any number, there is an exponent of 1. So that's what would be our final answer, class. 7 square root of x. So that would be our final answer. Do not forget, class, that in every square root, the index is 2. Okay, in every square root, the index is 2. And for x, there is an exponent of 1, so no need to write 1. So that would be our final answer. 7 square root of x. Alright, let's try number 4. So x raised to the power of negative 3 over 2. Once again, if you have a negative exponent, so the thing that you will do, class, is you need to get the reciprocal. So you still remember, class, in the laws of exponent, if you have a raised to the power of negative n, okay, raised to the power of negative n, the thing that you will do is you need to get the reciprocal. That would be 1 over a raised to the power of n to make this one into positive. Understood that there's 1 here, any number, any letter, there is a denominator of 1. Just get the reciprocal. So this one will be the numerator and this one will be on the denominator. Get the reciprocal and the exponent will be positive. I hope you still remember this one, class, in the laws of exponents. If you want to learn more about the laws of exponents, I will just put the link on the description down below. So you need to master class the laws of exponents before solving these radicals. Alright, so therefore, we can get the reciprocal of this one. Understood that there is a denominator of 1. So get the reciprocal. This will be 1 over x raised to the power of 3 over 2. X raised to the power of 3 over 2. And to convert this one into radical form, so this will be 1 over, so the square root of, so once again, this x, you put it inside, and this 2 will be the index. So understood that there's 2 here for the index, and this 3 will be the exponent of x. That's it, class. That's the answer there. Once again, we can still simplify this one in simplifying radicals, but we will not simplify in this part, class, because we are just told to convert rational exponents into radical form. Now, I hope you get this one, class. If the exponent on the numerator is negative, just put it on the denominator and the exponent will be positive. Now, if you have a negative exponent on the denominator, example number 5, just put it on the numerator and the exponent will be positive. I hope you got that one, class. So let's try number 5, class, for you to understand this one. So our answer for number 4, that will be 1 over square root of x cubed. Alright, number 5. So what if you have 3 over y raised to the power of negative 4 over 5? So once again, this is a negative exponent. To make this one into positive, just put it on the numerator. So this will be 3. Now since you put y on the numerator, you need to multiply the equations, class. Times y raised to the power of 4 over 5. Once again, class, if you have a variable, a number close to each other, it means multiplication. So do not add, class, it means multiplication. So this will be 3 times y raised to the power of 4 over 5. So that would be 3y raised to the power of 4 over 5. Alright, so once again, we make this one into positive. Just simply put this equation on the numerator and this equation will be positive. Of course, you need to multiply it by 3 because we already have 3 on the numerator. So that would be 3 times y raised to the power of 4 over 5. So that would be 3y raised to the power of 4 over 5. So since 3, the exponent of 3 is 1, simply copy 3. And for y, we can convert this one into radical. So radical form. And then copy y, put it inside the radical form. This 5 will be the index. And this 4 will be the exponent of y. That's it, class. Easy, right? So our answer, that would be 3/5 root of y raised to the power of 4. That's the answer for number 5. Alright, and that's it, class. That's the answer for number 5. So I hope you get this one, class, for writing rational exponents into radical form. So let's try to do the reverse, class. We have a radical form and we convert this one into exponential form or rational exponents. Alright, by the way, class, you try this one, number 6, and you put your answer in the comment section down below. Let me check if you really understand our topic. So what if you have, what if you have 5 over x raised to the power of negative 2 over 3? So how will you convert that one, class? Alright, convert this one, class. Pause the video and you try to answer this one, number 6, and you put your answer in the comment section down below for me to check if you really understand our topic. Alright, next video is we convert this radical form into rational exponents. So we have square root of 5 cube root of y squared. So let's have this one, number 1. Square root of 5. Alright, so to convert this one, very easy, class. Simply copy 5. Okay, copy 5. And then the numerator of the fraction, once again, understood that 5 here has an exponent of 1. So 1 will be the numerator of our rational exponent. And over this, understood, class, in every square root, there is an index of 2. Understood that there's 2 here. So that would be 1 over 2. That's it, class. 5 raised to the power of 1/2. Easy, right? So once again, to convert radical into rational exponents, this radical inside this radical symbol, copy. And this one, the numerator, came from the exponent of 5. Understood that there's 1 here. And then denominator 2 for the rational exponent, for the exponent, came from the index. And that's it, class. Easy, right? Let's try number 2. What if you have cube root of y squared? So once again, simply copy y, copy this radical y. So copy y. And then this 2 will be the numerator of the fraction. And then this 3 will be the denominator. 3 will be the denominator. This index 3 will be the denominator. That's it, class. That's how you convert this radical into rational exponents. Easy, right? Let's try number 3. So what if you have 4th root of 14x? So once again, as a whole, you copy this one. So you put quantity. So that would be 14x. So you put quantity, class, because we can make this one into a whole and the exponent is 1. So put quantity and the exponent is 1. So the exponent is 1. Okay, 1 will be the numerator and this 4 will be the denominator. That's it, class. 14x raised to quantity, 14x raised to the power of 1/4. Once again, class, if you have a number and a variable or 2 or more variables, the thing that you will do, class, is you need to put a quantity and then raise to the power of 1. This 1 here will be the numerator of this fraction and this 4 will be the denominator of the fraction. Okay? So that would be quantity 14x raised to the power of 1/4. I hope you get this one, class. So let's try an example, class. Example number 4. What if you have the cube root of 5xy squared? So you have a number and 2 or more variables. So once again, if you have a number and then 2 or more variables, the thing that you will do, you put quantity and this will be raised to the power of 1. So to convert this one into rational exponents, so copy this one inside the radical symbol, 5xy squared, then you put quantity. This one, okay, this one here for the exponent will be the numerator of the fraction. And this 3 will be the denominator of this rational exponents. That's the answer, class, for number 4. I hope you get this one, class. Number 5, let's have this example. 7 cube root of x. Now, since the exponent of 7 here is just 1, so the thing that we will do, simply copy 7. And for this one, copy x. And the exponent is x. The exponent is 1. Understood that there's 1 here. So the numerator of the fractional exponent is 1. And the denominator is 3. So that would be 7x raised to the power of 1/3. That's it, class. Let's try number 6. What if you have cube root of, so you have 3 over 4. The cube root of 3 over 4, the cube root of 3/4. So once again, the thing that you will do, you put quantity, since you have a numerator and denominator and the exponent is 1. So this will be copy 3 over 4, quantity, so the exponent is 1, and then this 3 index here will be the denominator. That's it, class. So if you have a numerator and denominator, just put quantity, the exponent is 1. So you can copy this one, quantity 3 over 4, this one here will be the numerator of the fraction, and this 3 will be the denominator of the fraction. That's it, class. That's the answer for number 6. Alright, let's try number 7. Quantity 3, the cube root of 5y raised to the power of -2. So quantity, the cube root of 5y raised to the power of -2. Once again, if you have a negative exponent, the thing that you will do is you need to get the reciprocal. Put this one on the denominator. So this will be 1 over, okay, understood, class, that in every equation there is a denominator of 1. Just get the reciprocal, class. Understood that every equation there is a denominator of 1, get the reciprocal. Just put this one on the denominator and the exponent will be positive. So this will be 1 over, okay, 1 over the cube root of 5y, raised to the power of 2. So the exponent now will be positive. Now since the exponent will be positive, we can convert this one into rational exponents. Alright, so next step, this will be 1 over, so we can write this one, class. Once again, this exponent 2, we can put this one inside, class. You still remember that the nth root of a raised to the power of m, we can also write this one as quantity the nth root of a raised to the power of m. So this is actually the same, class. So therefore, this 2, we can put this one inside this radical symbol. Okay, we can write this one as, this will be the same with, okay, this will be the same, the cube root of 5y raised to the power of 2. So you put parentheses, class, because this is 1 or 2 variables. So quantity 5y raised to the power of 2. And the final answer will be 1 over, so copy 5y, put quantity. This 2 here will be the numerator of the fractional exponent, and this 3 will be the denominator. That's it, class. That's the answer for number 7. So quite tricky, right? So let's try last example, class. Number 8. Then I will give you one assignment for this one. So number 8. What if you have 1 over quantity the 5th root of x raised to the power of negative 4. So once again, if the exponent is negative on the denominator, just simply put this one on the numerator and the exponent will be positive. So this will be, let's put this one on the numerator to make this one into positive. So this will be quantity 5th root of x raised to the power of positive 4. So this negative will be positive. Now once again, you can also write this one as the 5th root of x raised to the power of 4. So this is actually the same, class. Just put this 4 inside this radical symbol. Okay, this 4 will be the exponent of x. This is actually the same. And to convert this one, this will be x, copy x. This 4 will be the exponent 4 will be the numerator of the fractional exponent, and this 5 will be the denominator. That's it, class. That's the answer for number 8. Alright, let's try, or you try this one, class, number 9. And you put your answer in the comment section down below. What if you have 3? Then let's have the 5th root or 6th root of x raised to the power of negative 2. So you try this one, class, number 9. And you put your answer in the comment section down below. Let me check if you really understand our topic. Now if you have some questions, class, in converting rational exponents into radical and vice versa, feel free to leave a comment, class, on the comment section down below so that we can answer this one. You can also message me in our Facebook channel, same name with our YouTube channel. I hope you learned something new today. Do not forget to like, share, and subscribe. You share to your friends and to your classmates so that we can help more students. Once again, this is Teacher MJ. Have a great day, class. Goodbye for now. Bye-bye.